Okay, so, okay, I've got good news for you guys today. The method that we're going to learn to solve systems of equations today is the easiest of all the methods. Okay, so that's really, really good news. We're going to spend all week on this. We're going to take it pretty slow. So keep in mind, we started off solving by graphing, which is just the visual way to see, okay, here's what we're finding. We're finding the point where they cross, because the point where those two lines cross is the point that's located on both lines, which means it's the point that's the solution to both equations. And then we said, okay, well, graphing was fun and all, but not really that convenient. I mean, you gotta have graph paper, you gotta make sure you do everything correctly, all of that, and some of your answers that you guys had were fractions and decimals, that'd be really hard to find on a graph. So then we learned how to solve by substitution, which, the easier ones that were set up nicely for you weren't too bad, but some of them were a little tricky. So what we're going to learn today is how to solve systems by what's called elimination. And like I said, this is the easiest way to solve systems of equations. So we're going to spend 2 days on this. Okay, so to solve systems by elimination, 5 steps here. First thing, line up the equations. Now, what I mean by line up the equations, you want your x's lined up. See here how it's 2x and 2x. You want your y's lined up. See how your y's are lined up. You want your equal signs and then your constants lined up. So everything that looks alike should be just right on top of each other. Okay? What you're going to do next is you are either going to add or subtract the equations. I'm going to explain to you how you're going to know whether you're going to add or subtract. Then what happens is you're going to solve that resulting equation. That's going to give you either your x or your y. It's going to give you one or the other. And then you just have to find the other one, which is what we did last week. So let's look at this first one here. So the biggest thing with solving by elimination is you have to decide whether you're going to add or subtract your equations. So if you notice, they are lined up, x's, y's, equal signs, constants. And what I see that tells me I'm going to add is I have opposite coefficients. So opposite means one's positive, one's negative. Okay? But it's got to be the same number. So what you're looking for, and this is the easiest way to solve systems of equations, what I'm looking here at as I'm looking at the y's. So you see I have a negative 2y and a positive 2y? That's what we want. That's like gold right there. Okay, that doesn't have to be a 2. It could be a plus 4x and a negative 4x. It could be a plus 10y and a minus 10y. It doesn't matter whether it's an x or a y. It doesn't really matter what the number is, but as long as it's a positive and a negative and the same number with the same variable. Okay? If you see this, it's set up for you, ready to go. What you're going to do is you are going to add the equations, just like this. Now here's why everything had to be lined up. Because when I add the equations, I can't add the x's and I can't add the y's, but I can't add an x and a y. So if I have it lined up, it's just really nice and easy for me to add. So I'd take 2x plus 2x, which gives me 4x. But watch what happens with the y's. I have a negative 2y and a positive 2y. Remember how we're looking for those opposite coefficients? What happens with a negative 2y and a positive 2y? Yeah, they cancel out. Okay, you're going to drop down your equal sign, and you're going to add everything. So we're going to take negative 8 plus 4, which is negative 4. Now look at this simple equation that I get to solve now. To solve for x, we divide by 4, we get x equals negative 1. So guess what? Your answer, just like we did last week, your answer is an x comma y. So your answer is negative 1 comma something. Now this is the part that probably takes the most time today, but we already did this last week. If I know what my x is, in order to find my y, you're going to take this and plug it in for x in either equation. It doesn't matter which one, as long as you plug it in for x. I think for this one, that second equation might be a little bit easier. So I'm going to do 2 times, instead of x, I know that x is negative 1, plus 2y equals 4. And then we're going to solve for y. So 2 times negative 1 is negative 2, plus 2y equals 4. To solve for y, we'd add 2 and we would get 2y equals 6. Divide by 2, we'd get y equals 3. So your answer is -1. Yes. The negatives right here. 2 times -1. Yep. So, I mean, if you look at this, the part that took the most work is what I had in orange here, which is plugging the number back in, which we did that last week. That part's not new. The part that's new is this easy part right here. Okay? Now, if it's set up so the coefficients are already opposite, so a plus 2y and a minus 2y, those are the easy ones. But sometimes they're not going to be set up exactly like that, so there's one extra thing that you have to do. So if you don't have opposite coefficients, but you have matching coefficients, meaning they're the same number, not opposites, but the same number. For example, like a 3x and a 3x. Close, but the thing is, a 3x and a 3x are going to cancel out. One of them has to be positive, one of them has to be negative. So what we're going to do is we're going to make one of them negative. What you're going to do is you are going to subtract the equations. Now here's the big thing, and this is what you have to be really careful on today. When you subtract, you're going to subtract, it really doesn't matter which equation you subtract. I think it's easier just to subtract the second one. But you have to subtract the entire equation. You can't just subtract the 3x, okay? Really what you're going to end up doing is you're going to go through, and when you subtract the entire equation, subtract every single term here, you're going to go through and just change all of the signs. So the 3x turns to a negative 3x, the minus 4y turns to a plus 4y, and the negative 5 turns to a positive 5. So really all you do is, if you notice you have matching coefficients, go through, change all the signs. Now, I want to explain to you guys why I'm able to do this, why I'm able to change all the signs. What I'm really doing here when I subtract the equations is I'm multiplying both sides of the equation by -1. And I can do that. I can multiply both sides of an equation by the same number, and when you multiply by -1, it just flips all the signs. That's why we're able to do that. Now, it's actually kind of like we have what we did over there. Now we have opposite coefficients, so I can add those together. 3x and -3x, those are going to cancel out. 2y, this is now a positive 4y, so 2y plus 4y gives me 6y, and then 7 plus 5 gives me 12. And then to solve for y, divide by 6, we get y equals 2, which remember, my answer is something, comma something. That's your y, so your answer is something, comma 2. And then, in order to find the x, this is the same thing we did last week. You're going to take that 2, and you're going to plug it into either one of these equations. It doesn't matter. You could plug it in here. You could plug it in here. What you will need to be careful about, if you do decide to plug it into that second equation, you either have to plug it into the original equation, the 3x minus 4y equals -5, or the new equation where you changed all the signs. But you have to be really careful that you can't mix and match those. Since that happens, I usually plug it into the other one that I didn't change. That way I know I have it correctly. So we'll have 3x plus 2. Instead of y, we just found that y is 2 equals 7. So we have 3x plus 4 equals 7. Subtract 4 from both sides. So we get 3x equals 3. Divide by 3, we get x equals 1 for an answer of 1. That's what we're doing today. Not too bad, right? Okay. Let's get this glued into page 55. This is 6.3. We are solving by elimination. X and a -5x, or a 3y and a -3y. So we're trying to make them opposite coefficients if they are not already opposite coefficients. Okay. Number 1, 5x minus 6y equals -32, and 3x plus 6y equals 48. So the first thing we want to do is we want to make sure everything's lined up. Your x's, your y's, your equal signs, your constants. Most of the time they're going to be lined up, but sometimes they won't, so you just need to double check that. Okay, if you look at your x's, it's a 5x and a 3x. A 5x and a 3x aren't going to cancel out, and even if it was a 5x and a negative 3x, they're still not going to completely cancel out. So I'm not looking to cancel out my x's here. But if you look at your y's, you see how you have negative 6y and a positive 6y? That's what we want. They're already opposites. That's what we want. We want a negative and a positive. So we're going to go ahead, we're going to add them together. Because when you add a negative 6 and a positive 6, they cancel out. You're trying to eliminate, you're trying to cancel out one of your variables. And then you're going to add everything else. So 5x plus 3x gives me 8x. Negative 32 plus 48 gives me 16. And then to solve for x, divide by 8, we get x equals 2. Which, remember, means that your answer is 2 comma something. So just like we did last week, if x equals 2, you can take that 2 and you can plug it in either in the first equation or the second equation. It doesn't matter as long as you plug it in for x. I might plug it into the second equation and make it looks maybe just a little bit easier. So we do 3 times 2, plug it in for x, plus 6y equals 48. 3 times 2 is 6, plus 6y equals 48. Subtract 6 from both sides. So 6y equals 42. Divide by 6, we get y equals 7, for an answer of 2 comma 7. So like I said, I think the hardest part today, the most time-consuming part, is this part right here. That's not new. We had to do that last week, whenever we did substitution. Okay, number 2. 3x plus 3y equals negative 9. And 3x minus 4y equals 5. Now really what I'm looking for is I'm looking for like the easiest way out possible. So I'm looking to see if anything will cancel out just as it is. But a 3x and a 3x, they're not going to cancel out. A 3y and a negative 4y, they almost cancel out, but not completely. Okay? But if nothing's going to cancel out just exactly as it is, like in the other one, what you're looking for is, okay, well, I do have a 3x and a 3x. I just need to change one tiny thing, right? One of these needs to be a negative 3x. Because if it was 3x and a negative 3x, those would cancel out. So to do that, it doesn't matter if you do the first equation or second equation. I usually do the second equation, just for consistency purposes. So we're going to multiply both sides of the second equation by negative 1, which just flips all of the signs. Not just one of the signs, all of them. It's going to be a negative 3x, a positive 4y, and a negative 5. Now, once you flip the signs, then you're adding, you're combining. Because when I combine a 3x and a negative 3x, they cancel out. When I combine a 3y, and this is now a positive 4y, I get 7y. And when I combine negative 9 and negative 5, I get negative 14. Divide by 7, so we can solve for y. We get y equals negative 2. So that's going to be the second part of my answer. So then to find the x, take that, plug it into either equation. As long as you plug it in for y, it doesn't matter. And remember what I said on the left-hand side of your notes, though? If you plug it into the second equation, you just have to be really careful and make sure you either go with the original equation or the new equation with the changed signs. I usually just don't even worry about that, and I just plug it into the one that I didn't change. So we're going to do the first equation, 3x plus 3 instead of y. We know that y is negative 2 equals negative 9. So 3 times negative 2 would give me 3x minus 6 equals negative 9. Add 6 to both sides. We'd have 3x equals negative 3. Divide by 3, we get x equals negative 1. So your answer would be negative 1, comma negative 2. What do you guys think? Easier in substitution? I mean, I think so. Maybe a little biased on this method. Okay, number 3. Let's try 3x plus 4y equals negative 22 and 5x minus 4y equals 38. So what we're really looking for is we're hoping and praying that it's going to cancel out all by itself. And if you look at this, what's going to cancel out? The y's. Yeah, it's already set up for you. So go ahead. If the y's are going to cancel out, just combine them together. When you combine them, the y's cancel out. When you combine your x's, 3x and 5x gives you 8x. Drop down your equal sign. And when you combine the constants, negative 22, when you combine that with a 38, you get 16. Combine, add, all means the same thing. Divide by 8, we get x equals 2. Which means your answer is 2 comma something. So you're going to plug in 2 into one of those equations. Doesn't matter which one. You will get the same answer either way. If I plug it into the first one, we do 3 times 2 plus 4y equals negative 22. 3 times 2 is 6 plus 4y equals negative 22. Subtract 6 from both sides. So we have 4y equals negative 28. Divide by 4, we get y equals negative 7. For answer 2 comma negative 7. Number 4. Number 4 says 2x minus y equals 4. And 3x minus y equals 2. Now for this one, as it is anything going to cancel out? 2x and 3x, negative y and negative y. Will a negative y cancel out a negative y? No, because they're the same sign. They're not going to cancel out if they're the same sign. But if they were opposite signs, if this was a plus y, they would cancel out. Okay, but you can't just magically change that to a plus. If you're going to change this, you have to change all of them because you're going to have to multiply both sides by a negative 1. Now, once you flip the signs, you're combining, you're adding. So we're going to take 2x and a negative 3x. 2x and negative 3x gives you negative x. The y's cancel out. 4 and negative 2 gives me a positive 2. And I don't want negative x, I want a positive x. How do you make a negative x a positive x? Divide by negative 1. Make sure you divide both sides by negative 1, which just flips those signs, so we would get x equals negative 2. So your answer is negative 2 comma something. Like the other ones, take that in. I'll probably plug it into the first one because I didn't change anything about that first equation. So we'll do 2 times negative 2 minus y equals 4. 2 times negative 2 is negative 4 minus y equals 4. Add 4 to both sides. So we have negative y equals 8. Just like with the x, we don't want negative y, we want a positive y, so we'll divide both sides by negative 1, which flips those signs. We have negative 2 comma negative 8. Okay, the last two problems, something happens in these last two problems that's not going to happen in your 4 problems that you're going to do today for homework, but it will happen on your homework tomorrow. Okay, so keep that in mind when you're working on your homework tomorrow. So number 5 says 2y plus x equals 3. And x minus y equals 6. What's different about this one? They don't line up. They kind of, at first glance, look like they line up because you've got, right, your variables on one side, the equal signs on the constants, but I've got the y on top of the x and the x on top of the y, and I don't want that. I can't do that because if I was trying to add these together, right, at first I'm like, oh, a plus x and a minus y, opposite signs, but you can't combine an x and a y. So the first thing you have to do here, you're going to have to rewrite one, sometimes both of your equations to make them match. Now this one's easy to do because the x's and y's are on the right side, they're just not in the right order. So really, I kind of like to just stay consistent, and I like it when it says x, y equals signs constant. So the second equation says x, y equals sign constant. The first equation doesn't. What I really want to do is just flip this around. Well, I can do that. 2y plus x, that's the same thing as x plus 2y. So all you have to do for that one, just flip those around. Now they match. Now, is anything going to cancel out? As it is. So now we're working with these two equations here. Is anything going to cancel out here? No. So we've got an x and an x, right? One of them needs to be a negative x. So in that second equation, if I do negative x, yes. So if you were to combine a negative y and a 2y, you'd still have a y left, right? We don't want anything left. I want them to completely cancel out. So if this said negative 2y, we'd be in business, okay? So yeah, instead we're going to cancel out the x's because an x and a negative x, those will completely cancel out. But you can't just change the sign on the x, you also have to change the sign on the y and on the 3. Now my x and my negative x are going to completely cancel out. Negative y and negative 2y gives me negative 3y. 6 and negative 3 gives me 3. Divide by negative 3, we get y equals negative 1. So my answer is something common negative 1. And you kind of have three options here. You could plug this negative 1 in right here or right here. It really doesn't matter. That second equation might be the simplest, even if it's not quite the easiest, but this brings up a good thing that I have questions about. When you plug in negative 1 for y, you're going to do x minus negative 1. What happens when you minus a negative 1? It turns to a plus 1 equals 6. And subtract 1, we should get x equals 5. So your answer would be 5, comma negative 1. Okay, last one. Okay, number 6. 3x equals 2y plus 8 and 2x minus 2y equals 5. So you're looking at this one and at first glance, it's all messed up, isn't it? Right? It's not even just like a simple flipping one around. Now, like I said, I just think for consistency's sake, for me, I kind of like having it x and y's equal signs constants. So the second equation says x, y equals sign constant. The second equation is fine. The first equation is where the problem's at. Now, the first equation has the x on the right side, but you see how it's not even just a simple, like, flipping it around? The y is on the wrong side of the equal sign. I need it on the left side of the equal sign. Not a big deal. How can I move the 2y to the other side? Yeah, subtract 2y from both sides. So we have 3x, sorry. The 3x that was already over there. When I move the 2y, I now have a negative 2y on that side. And now the only thing left on the right-hand side is the 8. Now you have x's, y's equal signs constants. Is one of my variables going to cancel out right now? No. But I have a negative 2y and a negative 2y. If they were going to cancel out, one of them would need to be a positive 2y. But remember, you can't just change one of the signs. you have to change all of them because we're multiplying both sides by a negative 1. So when I combine my x's, 2x and negative 3x gives me negative x. My y's cancel out. 5 and negative 8 gives me negative 3. And then to get rid of the negative in front of the x, divide both sides by negative 1. So we should get x equals 3. So your answer is 3 comma something. Got options here. You could plug it in here for x, here for x, or here for x. It does not matter. Any preferences? This one? Okay. So let's do in this second one right here. So we'll do 2 times. Instead of x, we'll plug in our 3 minus 2y equals 5. 2 times 3 is 6. Minus 2y equals 5. Subtract 6 from both sides. We have negative 2y equals negative 1. And then finally divide by negative 2. A negative over a negative would be a positive. And you could turn it to a decimal if you wanted, or just leave it as 1/2. Yes?
There actually would be an easier way to do it, or you might have to do 2 steps. So the first part,
What's that?
you would minus negative 3 and then minus the 8, and you basically like switch the roles and add them. And then so you don't have to,
Right here?
meaning at the top part.
Here?
Yeah, you would minus the negative 3, or negative x3, I should say. And then you
right
would
here.
put on that side, and then you minus 8, and then you would have to,
So move the 3 to the right side.
yeah. And then
Now you would have to just make sure that whenever you do add your equations, it doesn't have to look like x, y equals times consequentials to highlight. You would just have to make sure your x's are on the same side of both equations. So if what you're saying is to move the x over, you would also have to make sure the x in this equation is on the other side as well. So you would have to be kind of careful with that. So, yeah, but there's definitely other ways to do this one.